Bristol Community College, Mathematics with Dan Avedikian, Math 060, Topics in Developmental Mathematics, Section 4.2, Problem 15. This is Section 4.2, Problem 15. It says the given triangles are similar. Find the length of the unknown side. So we have two triangles. The unknown side is the bottom of the left triangle. So what we'll do is set up a proportion. So the left side of the left side, you'll have 3 over 16. Oh, sorry, 1.6. Missed the decimal at first. Set that equal to n over 8. So now we have two fractions that are equal to each other. Find the solution by cross-multiplying and dividing. So as you multiply across one way, we'll have 3 times 8. And multiply the other way, 1.6 times n. And they're equal. So 1.6 times n we can just call 1.6n. 3 times 8 is 24. Now to solve for n, what we do is divide out the 1.6. We'll divide 24 divided by 1.6. So 24 divided by 1.6. Well, when you have a decimal and a number out in front of the division symbol, what you have to do is move it as far as you have to until it gets to the right end. So you're going to move it one spot. So you have to move it the same number of spots for the number under the division symbol. There's no decimal written in 24, but you're going to assume that it's at the end. So if you move it one spot, it becomes 240. So 1.6 divided into 24 is the same as 16 divided into 240. You can look at it this way and not really worry about the decimal. So 16 divides into 2, it doesn't fit. 16 divides into 24, it will fit once. 1 times 16 is 16. Subtract 24 minus 16 is 8. Bring down the next digit, which is a 0. Now 16 divides into 80. 5 should make it fit. Let's try it. 5 times 6 is 30. Write the 0, carry the 3. 5 times 1 is 5. 5 plus 3 more is 8, and it does fit exactly. 80 minus 80 gives you a remainder of 0. So the answer is 15. So the length of the unknown side is 15.